So we're going to be doing a problem in section 5.1. Problem number 6 is the first one we're going to be doing. And we're asked to find 6 different values for our function, our composite function, g of f of 0. I'm going to rewrite each one of these composite functions so I have a better understanding of what it is I need to do. So I need to put a 0 in to my f function. That's the first thing I'm going to need to do. So I put a 0 in wherever I have an x in my f function. And then I end up with g of the square root of 3. Then I need to put the square root of 3 into my g function wherever I have an x. So it becomes the square root of 3 squared plus 1. The square root of 3 squared removes my radical. I end up with 3 plus 1, which is equal to 4. The second part is f of g of negative 1, and you'll see that I rewrite each one of these functions so that I have a better understanding of what I'm doing. I need to put negative 1 into my g function, so I still have f on the outside. I'm putting in negative 1 into my g function, and I end up with f of negative 1 squared is 1 plus 1, which gives me f of 2. So now I have to figure out what f of 2 is. I'm going to put in a 2 into my f function wherever I have an x. It ends up giving me the square root of 1, which is equal to 1. The third example is f of 2. So again, what I get as my output for f of 2, I'm going to put as my input back into f. So I'm going to take the square root of 3 minus 2, which gives me f of the square root of 1, which gives me f of 1. Now I'm going to put that value back into my f function, and I end up with the square root of 3 minus 1, which gives me the square root of 2. The fourth thing we're supposed to do, g of f of negative 3. So that I can rewrite as g of f of negative 3. I need to put a negative 3 into my f function wherever I have an x. So 3 minus, and then put in your negative 3. And that gives me g of the square root of 3 plus 3, which gives me g of the square root of 6. So now I need to put the square root of 6 into my g function wherever I have an x. So g of the square root of 6 is going to give me the square root of 6 squared plus 1. Square root of 6 squared is 6 plus 1 gives me an answer of 7. The next one tells me I need to find f of g of 1/2. So rewriting, I'm going to put 1/2 into my g function. So I'm going to have 1/2 squared plus 1. This gives me f of 1/2 squared is 1/4 plus 1. And then I need to find a common denominator to be able to add the 1/4 and the 1. My common denominator is going to be 4. So I end up with f of, this equals f of 1/4 plus 4 over 4. So now I'm going to put back into my f function 5/4. So I have the square root of 3 minus 5/4. I need to combine these two. I need to find a common denominator. Common denominator again is going to be 4. So this gives me the square root of 12 over 4 minus 5 over 4. Simplifying, I end up with the square root of 7 over 4. And then I can split my radical and rewrite this as the square root of 7 over the square root of 4, which gives me the square root of 7 over 2, simplifying that. The last composite function we're going to look at is f of negative 2. So I'm going to put in a negative 2 into my f function. So doing that, I end up with f of the square root of 3 minus a negative 2. Make sure you use your grouping symbols, which gives me f of the square root of 3 plus 2, which tells me I need to find what the value of f of the square root of 5 is going to be. So going back into my f function again, I'm going to have the square root of 3 minus the square root of 5. And that's as simplified as we're going to get on this particular problem. The next problem we're going to look at is number 10. Number 10 is f of x equals x over x plus 5. G of x equals 2 over 7 minus x squared. And we're going to go through the same process that we just went through. The first thing we're asked to find is g of f of 0. And again, I'm going to rewrite each one of these so I make sure I don't make any mistakes. So into my f function, I'm going to put a 0. So I have 0 over 0 plus 5, which gives me 0 over 5, which gives me 0. Now that's what f of 0 is. I should have put these all inside of my g function. So now I need to find g of 0. So I need to put a 0 into my g function wherever I have an x. And when I do that, I end up with 2/7. The second composite function is f of g of negative 1, which gives me f of g of negative 1. So I'm going to put a negative 1 into my g function. When you do this, make sure you use grouping symbols. We're going to take 7 minus, and then x is going to be squared. Make sure you follow your order of operations, which says that I need to square before I subtract. So 7 minus, and then negative 1 times negative 1 is a positive 1. So now I need to find f of 2/6, which is the same as f of 1/3. So into my f function, I'm going to put 1/3. I end up with 1/3 over 1/3 plus 5. Now looking at this function right here, to simplify this complex fraction, I'm going to multiply both the numerator and the denominator by 3, because that is the LCD of my numerator. It also happens to be the LCD of my denominator. So I'm always looking for the LCD of the entire fraction. In this case, it's 3. So I'm going to multiply my complex fraction by 3. In essence, I'm multiplying by 1. So I haven't changed the fraction. I'm just rewriting it. I have 1/3 times 3 over 1/3 times 3 plus 5 times 3. So make sure that you multiply every single term by 3. You have to make sure you use your distributive property there. So in the numerator, my 3's cancel out. I'm left over with 1. In the denominator, I'm left over with 1 plus 15, which gives me 1/16. The next composite function is f of 2. So we have f of 2. So I'm going to put 2 into my f function wherever I have an x. And this gives me f of 2/7. Then I'm going to put f of 2/7 back into my f function. So I end up with 2/7 over 2/7 plus 5. Once again, I'm going to look for my LCD of the entire fraction, which again happens to be just the denominators that we're dealing with here. So 7 divided by 7. I'm going to take 2/7 times 7, do the same thing in the denominator, and make sure that you multiply 5 times 7 also. So this ends up being 2 over 2 plus 35, which gives me 2/37. Next composite function we're looking at is g of f of negative 3. And then rewrite it. Make sure you do the right things. Carry through the problem correctly. So I'm going to put negative 3 into my f function. So I have negative 3 over negative 3 plus 5, which means I'm going to have negative 3 over 2, or negative 3/2. I'm going to put negative 3/2 into my g function, which gives me 2 over 7 minus a negative 3/2. And again, make sure that what we're multiplying by itself is your x, and we're subtracting that from 7. So now we have 2 over 7 minus 9/4. My LCD for this particular problem, the numerator, the least common denominator is 1, and the denominator, the least common denominator is 4. So 4 times 1 is 4. That's my LCD. And I'm going to multiply every term in the numerator by 4 and every term in the denominator by 4. Oops, subtract 9/4 times 4. When I do that, you should see that these guys cancel out, and I'm left over with 8 over 28 minus 9, which gives me 8/19. The fifth composite function we're going to look at is f of g of 1/2. Rewriting, I'm going to need to find g of 1/2 first. So I'm going to put a 1/2 in wherever I have an x in my g function. In this case, I have to square it. So I have f of 2 over 7 minus 1/4. I'm going to want to simplify this complex fraction before I put it into my f function, so I'm going to multiply both the numerator and the denominator by 4. So I'm going to be multiplying by 4 over 4. So f of 2 times 4 over 7 times 4 minus 1/4 times 4. So I'm multiplying every term in my function, my complex fraction, by 4. So this ends up giving me f of 8 over 28 minus 1, which gives me f of 8 over 27. Now I'm going to put 8/27 into my f function. So f of 8/27 into my f function gives me 8/27 over 8/27 plus 5. And I want to simplify this. I'm going to multiply both the numerator and the denominator by 27. So now I end up with 8/27 times 27 over 8/27 times 27 plus 5 times 27. My denominators cancel out, and I'm left over with 8 over 8 plus 135, which gives me 8 divided by 143. The last composite function we're going to look at is f of -2. Rewriting, I'm going to put in a -2 into my f function wherever I have an x. This simplifies to f of -2/3. Now I'm going to put it back into my f function again wherever I have an x. So f of -2/3 ends up being -2/3 divided by -2/3 plus 5. I'm going to multiply both the numerator and the denominator by my LCD. I'm going to make sure that I carry through my distribution. And when I do that, I end up with -2/3 times 3 over -2/3 times 3 plus 5 times 3. The denominator should cancel out, and I'm left over with -2 over -2 plus 15, which ends up giving me -2/13.